Okay, 33-1, the Pythagorean identity. We have two learning targets: prove the Pythagorean identity, and then our second learning target, which is full of really bad grammatical and spelling and just totally bad. Use the identity and sine, cosine, and tangent to solve given the value of one of the functions. So essentially, we're going to find the identity, and then with that, we are going to use that to solve for sine, cosine, and tangent. All right, that's what that mess of a sentence says right there. We'll start by using an excerpt from Springboard. So look at the ratios that were defined in the previous lesson of the unit circle, where the length of the hypotenuse is equal to 1. So we're given that sine of theta is equal to y over 1, cosine of theta is equal to x over 1, tangent of theta is equal to x over y. Essentially, let me just draw this for you really quick. Here I have a right triangle. This is 90 degrees. We'll call this theta. It doesn't really matter what theta is, but we'll call that theta. We know that this side is my x, this side is my y, and of course my hypotenuse was always 1, which we've talked about a few times, that your hypotenuse is always 1 in your unit circle. If I want to find sine of theta, sine is so, or opposite over hypotenuse. Opposite is y over hypotenuse, which is 1. So sine of theta is y over 1. And then we can continue that for cosine and tangent and get those three identities: sine of theta, cosine of theta, and tangent theta. Since sine of theta is equal to y and cosine of theta is equal to x, we can write the tangent theta in terms of sine and cosine. In other words, tangent of theta is equal to y over x, so tangent of theta is equal to sine of theta over cosine of theta. I know that's a lot. We're going to prove it. Now, in geometry, you did a lot of two-column proofs, right? The what and the why. Here, I don't really care about the two-column proofs. This is more of an informal proof of us just going through this, and our goal is this. Our goal is, can we prove that tangent theta is equal to sine of theta over cosine of theta? That's our goal. All right, well, let's start with what we know. We know that sine of theta is equal to y over 1. So sine of theta is equal to y over 1. Okay, if I want to get this by itself, well, how do I get rid of this fraction? I'm going to multiply both sides by my denominator, or 1. So I'm going to multiply this side by 1. I'm going to multiply this side by 1. When I get that, I do 1 times sine of theta is equal to y, because these are going to cancel out. 1 times sine of theta is equal to y. Well, anything times 1, very simply, is just sine. So sine of theta is equal to y. Now, we kind of already know that, because we know that from our last, or I guess Tuesdays, we know that my coordinate points go cosine, sine. It's alphabetical. Cosine is your x's. Cosine is your x. And sine is your y. So, we know that sine is y, right? That's y, W-H-Y. That's why we have this. Sine is y. I'm going to skip the next part and just say, because of what we just talked about, cosine of theta is equal to x. So cosine of the angle is equal to x. With that being said, if we know that tangent of theta, we know that tangent to theta is y over x, well, we said y is this, x is this, and if tangent theta is equal to y over x, then tangent theta is equal to sine theta. Right, please, theta over cosine theta. So tangent is sine over cosine. That is kind of a big key right there. If you know this right here, tangent theta is equal to sine of theta over cosine of theta, that's going to help you tremendously when you solve. You gotta know that first. All right. Well, how does this lead us to the Pythagorean theorem? What is the Pythagorean theorem? Well, if we look down to the next page, the Pythagorean theorem shows the following relationship between the sides of a right triangle. A squared plus b squared is equal to c squared, where a and b are the legs of the triangle and c is the hypotenuse. You know this. Okay, this is probably the biggest theorem in math. What was the one that I said earlier this year was pretty big? Oh, the fundamental theorem of algebra was pretty big. And then also that you can't have 0 in the denominator is massive. But the Pythagorean theorem, if you don't know by now, is easily the biggest theorem in math. That is the basic sense of it. A squared plus b squared equals c squared. What I want to do is find the trigonometry sense of it. I want to be able to have sine and cosine in there. All right. Here's my circle with my triangle in it, the unit circle. What I want to do is prove to you or develop the Pythagorean identity using this triangle. All right, we're also going to use what we talked about up here. Okay, let's do it. So, we know, first thing, sine of theta is equal to y. And sine is up and down, right? So sine would be, or y is up and down. So y would be right here. This would be sine of theta. Okay, that's what we're going to call that. Then we know cosine of theta is equal to x. My x is down here. This would be cosine of theta. Okay, so I'm just going to cross this out right here. I don't want to get confused. I'm going to cross this out and say I no longer have that. What I actually have is cosine theta sine theta. Okay, that's really what I'm working with as a coordinate pair. Cosine theta, sine theta. Again, branching off of what we talked about on Tuesday, which was seeing that coordinate point as cosine and sine. All right. Now, where does this lead with the Pythagorean theorem? A squared plus b squared equals c squared. Essentially, A, B, and C, if you look below, A and B are the legs of the triangle, and C is the hypotenuse. So this is C, right? That's the hypotenuse of the triangle. 1 squared. That is always 1. 1 squared. Now the two legs of the triangle, cosine is 1 leg, so cosine theta squared plus sine of theta squared is equal to hypotenuse, or c squared. Let me make this a little bit neater. Cosine squared plus sine squared is equal to 1 squared. Let's do a little bit of cleaning up. First of all, okay, so we're going to do a little cleaning up here. Cosine squared plus sine squared is equal to 1 squared. First of all, 1 squared is just 1. Right? 1 squared is just 1. We also don't typically write it like cosine squared plus sine squared. What you're more likely to see, and what mathematicians typically will say, is sine squared plus cosine squared. Sine theta squared plus cosine theta squared. Okay, sine theta squared plus cosine theta squared. This is more likely, and even more likely than that, it's not mathematically accurate to say sine of theta squared, because sine of theta squared would be sine of, like, for instance, if our theta, let's say, for instance, theta equals, we'll just make it easy, 10. Okay, sine of 10 squared is sine 100, which is not what I want. What I want is sine of 10 times sine of 10. Okay, this does not equal that. So how do I denote this? And just to make it a little bit easier, what I write is I typically will write sine squared theta plus cosine squared theta equals 1. Okay, the squared in front of the degree is just kind of a notation thing. It makes it clean. Please write it like this. That is how you write the Pythagorean identity. Sine squared plus cosine squared is equal to 1. This is our Pythagorean identity. Sine squared theta plus cosine squared theta is equal to 1. Huge, huge, huge identity in math when you get to pre-calc or calculus. This is very, very key. So the Pythagorean identity, sine squared theta plus cosine squared theta is equal to 1. You could also go ahead and throw a degree in there, right? So I did sine of 10. If I wanted to figure this out, and I wanted to solve for cosine, I would do sine squared of 10 plus what is equal to 1, and I would solve it just like an equation. I'll write it out for you just so you can see it. So I would do sine squared of 10 plus, again, I don't know cosine theta, so I'm going to put that is equal to 1. How do I solve that? Well, I'd subtract sine squared 10 from both sides, and I'd get cosine squared theta. A little bit harder to solve. We can do some of those problems later. But right now, I just wanted to make sure that you guys knew the Pythagorean identity. Right. Hopefully that, again, I know it's getting difficult. I know it's challenging. Stick with it. It'll all kind of wrap around the unit circle. Think of everything in terms of that unit circle.